everyone. Myself Kalpna. I am from G.K.Jain Higher Secondary School, Royapuram. Today for the 12th standard I am going to explain the topic is transition and the inner transition elements. Okay, in last videos we saw about the transition elements. So transition elements means D block elements. We saw the position, oxidation state, metallic nature, catalytic properties and alloy formation, all those things. And also we have saw the preparation of potassium dichromate. Okay, today we are going to explain about the preparation of potassium permanganate. So potassium permanganate, which is very similar to you, because in 11th standard we have using this solution as a burette solution. It is a purple in color. Okay, so it should be very similar in nature. So today we are going to see the preparation of potassium permanganate. Okay, so let's see the potassium permanganate. It has been divided as a cation, as a anion, cation and anion, K plus and MnO4 minus, and also it is as a formation of salt of permanganic acid. So permanganic acid means in place of K, it has been replaced by the hydrogen. So it will be formed as a permanganic acid. So today we are going to see about the preparation of potassium permanganate. It has been 2 steps have been involved in it. First step, the important ore of the potassium permanganate is pyrolusite. Pyrolusite is a ore which is used for the preparation of potassium permanganate. First step, we have to convert the pyrolusite ore into the potassium manganate. Then in the second step, by the oxidation, the potassium manganate which is converted into the potassium permanganate. So only the 2 steps which is involved in the preparation of potassium permanganate. Let's see. Before going to the preparation, we just see the some more formula for that. The pyrolusite MnO2, potassium manganate K2MnO4, then potassium permanganate KMnO4. So only 3 formula: MnO2, K2MnO4, KMnO4. That's all. These 3 formulas only which is involved in this preparation. So before going to the preparation, you should understand you should learn the few more formulas. Then if you are going with the preparation, it will be easy for you. Okay. In the first step, let's see the first step, pyrolusite, which is, so you have taken a ore pyrolusite which has been powdered and it has been fused with the potassium hydroxide, and here the oxidizing agent will be a air. So air is automatically oxygen. So 2 MnO2 plus 4 KOH, that means fused with the potassium hydroxide with the oxidizing agent of O2, which will be formed as a 2 K2MnO4 plus water molecules. So if you have remember, what should you do before that? You should remember these 3 formulas. Then if you have got with the step 1, pyrolusite which is fused with the potassium hydroxide, then with the oxidizing agent water, it should form the potassium manganate and the water. So these and all, it is easy to remember you. So after you are writing whatever the formulas you know, you have to write it. Then you have to balancing the equation. Just we see 1 or 2 balancing equation. First one, potassium, here we have a 4. Potassium will be 4 molecules. Here it should be 4K. So it is automatically balanced. So after the writing the equation, whatever known formula you should write, you should be know how to balance it. So before the reactant, the number of molecules which is equal to the after the product formation. That is the 2 things which will be easy. Then it will be easy for you writing that or attending the equations, because in chemistry most of them it will be related with the equation only, either in organic, inorganic, some other physical chemistry only, it should be some theoretical only. So by this way, if you are learning, it should be easy to understand the equations. Okay, next step 2. Step 2 is the oxidation state. So here potassium manganate, that means K2MnO4 which is converted into potassium permanganate KMnO4. In the oxidation state, it has also been involved 2 steps. One is a chemical oxidation, second one is the electrolytic. In a chemical oxidation, 2, so you just taken a potassium manganate, so MnO2, so we have taken an anion only, so that is why MnO4 2 minus plus ozone. In presence of ozone in a water, it will be formed as a permanganate. Hydroxide has been formed as well as the oxygen molecule. So this will be happen in the chemical method. And third, in the electrolytic method, it is under the alkaline solution. So how the alkaline have been dissolved? It has been dissolution. K2, potassium will be formed as well as the permanganate will be formed. Hydrogen H2O, it is also be H plus and the OH minus it has been formed. So let's see the anode formation in an electrolytic method. What are all the reaction which is take place in the anode? MnO4 2 minus which gives MnO4 plus electron which will be given release of electron. Those electron it has been treated with the hydrogen, it will be formed as a hydrogen gas, it has been liberated. So these are all the overall reaction which is involved in the preparation of potassium permanganate. So in a first step, pyrolyzed which is converted into potassium manganate into potassium permanganate, only which is very easy to understand it. Next we see about the structure of potassium permanganate. So the oxidation state of potassium permanganate is +7. So it will be having the tetrahedral shape. Let's see here, Mn double bond of O, so automatically 7 bonds is there. It is under the resonance structure. Let's see the resonance structure of permanganate. Here it has been, so all the sides, whenever you see the single bond, it has been replaced in all the sides. It means every side it should be having the same one. So it should be called it as delocalized because it have been take place in all sides when you seeing the resonance structure. Okay, so finally you getting this structure. Okay, so here some other one is a single bond, the other will be the dotted lines. So the dotted lines which indicate it should be a delocalized one because it takes all the place it has been delocalized. And the bond length is also been equal because when you go to see the resonance structure, all the single bond it take place one another. Okay, so that is why it should be a resonance structure. So the bond length is also be equal, and it is also the dotted line which indicate it should be a delocalized one. And next one, the potassium permanganate, which will be called it as a chameleon. Usually chameleon is an animal which will be indicate it take the color wherever it has been sit on the leaves or the bark of the tree, it will take the color of those object, isn't it? The same as will be the potassium permanganate. Usually it is a colored one, purple color, but whenever according to the color of the solution, it has been formed as a red, blue. Usually it is in a purple color, and it is also take part with the whatever the object it has been acted according to the reacting substance. So it will be formed some other colors also. That is why it should be called as a chameleon solution. Let's see the uses of the potassium permanganate. First one, it is a strong oxidizing agent. It is used for the oxidizing agent, the potassium permanganate. And second one, so it is a colored one. So that is why we are using for the dyeing and the printing printing industries and all. And next one, so these uses we already know. We have been used for the quantitative analysis in the laboratory. So in this video we have been saw about the preparation of potassium permanganate, structure of potassium permanganate, uses of potassium permanganate. For more educational videos, please subscribe our YouTube channels. Thank you.